Hey everyone, it's Hugo Anderson here, host of the Data, ML, and AI podcast, Vanishing Gradients. I recorded an episode recently with Hamel Hussein and Dan Becker, who I'm here with again. Hey, Dan.
Hey, thanks for having me.
Absolutely. And so we recorded an episode about many things, including what you and Hamel learned when teaching LLMs and fine tuning to thousands of students. There's a few things we chatted about which made us want to do this demo, which I'd love to jump into in a second. But first, for context, maybe you could just tell us a bit about yourself and what you're up to at the moment.
Yeah, so I've been a hobbyist data scientist for probably 15 or 20 years, and then worked professionally in AI for starting in about 2011. I finished second in a Kaggle competition with a $500,000 prize for first place, but no prize for second place. But ever since then, I've been working in AI. That includes some time at Google, founded a startup, ran a team for data robot building tools for data scientists. And then for the last year or two, I have been doing independent consulting using LLMs and generative AI. And then obviously teaching. You and I taught a deep learning course probably in the mid 2010s for data camp. And then recently did this course for Maven about fine tuning. And at the moment, I'm teaching a course on RAG with Jason Liu, the creator of Instructor.
Awesome. And a lot of other educational stuff as well. I mean, a lot of teaching data science and analytics and machine learning at Data Robot and building out their platform for doing so. And then Kaggle Learn, which you worked on at Google, which you spearheaded, was such a great initiative.
Yeah, that's right. So always been excited to share AI with others.
So, what prompted us to decide to do a demo along these lines? What did you learn in this course?
Okay, so I think that I've learned a couple things. People are very, very excited about AI. And you hear people talk about, you hear, for instance, Sam Altman talks about a Moore's law for everything. That is, every aspect of our life is suddenly going to have this new trajectory of improving at an exponential rate that we've never seen before for anything except for maybe microprocessors. And when I taught this course, we had 2,000 people, and everyone was interested in LLMs in the abstract and how large a model can I fit on a GPU and how does that change with quantization? And some very technical aspects, but very few people had ideas for products they could build or use cases. And I think as much as we're all excited about generative AI, if we can't figure out how to build useful products, then we're not going to get a Moore's law for everything. We're just going to get a lot of optimization of a narrow set of use cases. So that made me very excited to think more about useful products that could be built. And then coming back to this idea of a Moore's law for everything, I know that in my life and the lives of people that I interact with, a lot of the things we want are physical. And yet, most of the use cases that I've seen for LLMs are optimizing the same things online that we've been optimizing with data science for a long time and not crossing over from bits to atoms. So I've been very excited about trying to do things that help help people create things, real physical, tangible goods that will show up in their lives and that they can physically apply to solve problems. So that's the piece of software that is in a very, very early stage. This is pre-alpha. This is sort of a side hobby project I've just started on, but is something every time I use it, I have fun with it. And I think it can unleash the creativity and productivity for people who want to build physical things.
Well, let's jump in. And I love the framing of from bits to atoms. It reminds me of, I don't know if you watch a lot of The Simpsons, but Radioactive Man, who's Radio Wolfcastle, whose tagline slogan was "Up an atom." So let's do it.
Okay, let's do it. Here is the prototype app. And I'm a big fan of yours, but let's make a household item with your name engraved in it. So let's start with a cup with the name Hugo engraved in it. And
Incredible. I've always
we're
wanted one
going
of these.
we're going to create a 3D model of an object. Actually, we're going to have a bunch of different LLMs using different CAD languages. We're going to, as a result, show a bunch of different models of physical objects. Spatial reasoning is still quite challenging for most LLMs, and as a result, many of these 3D models are not going to be very good. That's totally okay. we're going to build a bunch of them. And as a result, if many of them are not good, we'll just ignore those. And then we are going to iterate within the software the same way that if you were using CAD software, you don't design everything exactly right the first time you touch your mouse. Instead, you try things and you go back and you move things around. So that's just part of the design process. And we will have the same design process here. So here you can see we've got one. The name Hugo is sort of floating about. So that's we wouldn't want to 3D print that. So we've got a number of different designs. Most of them are not really exactly what I want to 3D print, but I'll just pick
And we
one.
wouldn't
And actually,
expect them to be with the first prompt as well, right?
that's right. I'm going to take this one and I'm going to pick it. And now we're going to just iterate. So I'm going to say the name. Hugo seems to be loading on the inside of the cup. Have it be letters raised from the bottom inside of the cup and make the letters be pretty tall.
And while this is running, can you tell us anything about the models you're using? Or I don't want you to give away any trade secrets or secret sauce as well.
It's too early for me to think of anything as trade secrets. So, and let me also emphasize, I would really like to have people who have 3D printers and don't know what to do with them, which I think describes 90% of people who have 3D printers. Anyone who wants to try this, I'm not trying to monetize or anything, get in touch with me, Dan at buildgreat.ai, and I'd love to have people experiment with this. Going back to your question, the models are just all the mainstream models. So that would be, for instance, Llama, it's August 2024. So that would be Llama 3.1, GPT 4.0, Sonnet 3.5. So we're just trying all of them. And then for each of them, we're trying them, chain of thought versus not chain of thought. There are different CAD languages. So where you experimenting with just a lot of different versions, but the models are mainstream languages available through APIs. So here we
And
have a
this is
cup.
already looking better. So you're using the base models, you're not fine tuning on CAD prompts and this type of stuff.
That's right. I think
Um,
there's a future where we do fine tuning, and certainly a future where we embed more examples. We have some examples in the prompt, but we have more examples in the prompt. And you can imagine doing RAG to figure out what examples you embed in the prompt. So there are lots of things that I intend to do. This is just a hobby side project that I started maybe a month or maybe just even less than that ago. And so we're in the very early stages and there's no fine-tuned model yet.
and just one more question. The output of the model isn't this 3D image, right? It's code that
That's right.
then you use to render.
Yeah. So the standard format that if you have a 3D printer and you want to print something, the way that you import that into the slicing software that's specific to your printer is in a file. It's a format called STL. And if I click get STL, then I will download that file and now I can print that. And an hour from now, if I want it, or like this is a pretty small thing to print, probably 30 minutes from now, I could have that cup. I could be holding it in my hand. I could be drinking from a Hugo themed cup.
Incredible. And could you just show us the code under get code by any
Yeah.
chance?
So this is a relatively simple object. So as a result, this code is in a language called OpenSCAD, and we try a few different languages, but this I can tell by looking at it is OpenSCAD code. This is the OpenSCAD code that creates the STL file for that object, which is the one that we would 3D print.
Mm,
And if we wanted, we could make this, actually, it's a quite small cup. If I printed it right now, it'd be 8 by 8 by 12 centimeters. So I could make it be twice as large. I could make the letters come up 3 times as high. So those are all things I could do simply by asking.
amazing.
Tell you what, you want to see another object?
Love to.
Yeah, let's try. I have a daughter who really likes dogs. So let's start with a dog.
And while that's generating, I saw something that said upload image. So, I mean, what my intuition says is that you may be able to use the multimodal aspects of such models as well.
Yeah, a neighbor of mine is a s- I think that he would not be offended if I said a small time inventor. One of the things that he invented is at some campgrounds, they have two different types of plugs and they can't be used simultaneously. So he's got something that you cover the plugs with, And then the campground can do that so that you can use one of the plugs, the other one is blocked. So there's something that slides to one. And he said that if he wanted to use this, the thing he ideally would do is sketch it on paper and then show the image of his little sketch to the model. That's
Mm,
using the multimodal aspect, like you said. And so this is all just a way for however you want to input it, whether it is with text or whether it is with images that you sketch out, or I could even, show it a little stuffed dog and use that instead of describing the dog as a way to get my ideas into the machine.
mm.
And coming back, you can see like some of these are actually quite bad. Like these are detached. That comes back to LLMs as of August 2024 being really bad at just spatial awareness. And then also, like if a human were to write this code, if they didn't get to see their output, they just had to do it straight out. We would do no, I would do no better than this terrible option here the first time around. You can actually
Mm.
kind of see these are the legs, but I would do quite poorly. You would need to iterate. Fortunately, we be faster or getting many iterations simultaneously. So you can see here's one. This is not so bad.
No, it's like
Um,
a chubby chihuahua.
yeah, I'm not a Chihuahua fan, so I'm going to say make the legs longer,
But you're gonna
make
say
the
make it a Great
face
Dane or something.
less boxy. Oh, should we make it a Great Dane? Okay, let's see what happens here.
Very cool. Very interested in how Llama 3.1, as it's August 2024, compares for your needs to pinging vendor APIs.
The funny thing is that Llama 3.1 comes in various sizes. The largest that I use, I forget it's whatever, 72 or 70 or 80
Something like that.
billion parameters. That is meant to be roughly the same quality as GPT-4o mini. Both of those are really not very good. So both of those are worse than GPT-4o or Sonnet 3.5, and I think that's not a surprise. I have a hunch that if I were to run the 400 billion parameter model, that's the one that's supposed to be competitive with GPT-4o, but I have not done that yet. The For serving Llama 3.1, I'm using Grok, and I think that using Grok, it happens to be free at the moment. Hopefully, they'll let me get a paid account so I can use it more aggressively. Using Grok is a fantastic experience, and when you watch this app have the models pop up, you always have one or two that pop up way before the others. That's because we're using Grok. That's with Llama 3.1 on the 70 billion parameter model, and it just is much faster than the other models, so it pops in faster. So the real advantage of Llama 3.1, if you can't use the really big model, is that because you can serve it on Grok, you can serve it very quickly.
Great.
So let's look at a couple of these dogs. We're gonna have to talk to the model about our Great Dane. These are really not very Great Dane-like, but we can always iterate.
And for one or two iteration, I mean, I iterate a lot more to get
Yeah.
way, way less things
Um,
at what I think they will be in text.
yeah, so I'm gonna just
And at least we're
put
not
this.
hearing now, oh, I'm so sorry, I didn't do this. Of course I will do this for you in future.
Yeah, that's right. And if I if you were doing this with CAD software, no offense, but I'm guessing you haven't used CAD software. So how long would this take you? I don't know, a month?
Mm,
I've used some CAD software a good amount. This would probably take me a few hours even to get to the stage that this is at right now. And instead, while we're talking, it's taken a couple minutes. So it's about a 60x speed up. I think even for someone who's good with CAD software, this is still faster than they would be at this point. So
In all honesty, Dan, something I've got a bunch of friends who are architects who I've talked about, the implications of text to text models for their line of work, but I can't wait to show them this video and just get their thoughts on it and riff with them on it.
I think the upper bound in complexity for what we can do with this software is still lower than what can be done with CAD software. So I think for someone who's making a building, which is obviously much more complex than a plastic dog toy, I think that they'll say, maybe I'll be interested to hear their feedback. I think that it's actually not for them, but for the home inventor who's going to make something small. I think it actually is a nice way to make prototypes, print them out, see how they
Yeah, I
work.
mean, even thinking, I don't know anything about what I'm talking about, but thinking about structural engineering or buildings or that type, you could imagine that just generating templates could shave 10%, save someone 10% of their time.
Yeah. So one of the places that I want to take this in the future is for physical objects. If you want to design something that is actually functional, there's a lot of calculations that you would typically do. One of the techniques is finite element analysis. So one of the directions that I want to take this is one where the LM can do tool calling. And as a result, if I say I want a catapult, it doesn't just make me a catapult, but I can say I want a catapult. And if I print it with this type of plastic, I want it to be able to shoot a checker
Mm,
4 meters. And it actually figures out what are the parameters, how long does the arm need to be, and so on, in order to meet that functional requirement. And that doesn't exist yet, but I do. That's one of the directions that I'd really like to explore.
incredible. That's so exciting. So is there anything else you want to show us here now?
I don't think so. With my call to action, I've got the website
Mhm.
designbench.ai. So someone can either email me or just log in there, create their own account. You can do it in take 10 seconds. So I'd really encourage anyone who sees this, who's curious, especially if you have a 3D printer and haven't used it in a long time, try this out. And I'd love to see if you find it interesting and how I can improve it so that it's useful to people.
Fantastic. And you said Dan at buildgreat.ai.
Yep. Or if you just want to try it out without emailing me, designbench.ai is the one word. Design Bench is the website where this is being hosted.
Awesome. And for those of you who reached this video through the podcast episode, thank you so much for joining. For those of you who didn't, I'm going to put a link to the podcast episode below as well. So please check it out. Thanks once again, Dan, for your time and wisdom. Also, everyone, just a super quick update. It's been a couple of days since I recorded with Dan. And as you can see here, he's sent through some photos of the Hugo inspired cup that he 3D printed. So thanks once again, Dan. And excited to drink from this one day.